If the speed of light changes one day, will the world collapse? Many people think that it's just a matter of being faster or slower. But the first to fall is the order of time and the chain of causality. Because the speed of light is not just speed, it is the scale of the universe, the baseline of all physical laws. So next, we need to push this baseline forward a bit and then pull it back a bit. Let's see if atomic and stellar communication will all be lost in an instant. Then, the problem becomes sharp. If the baseline itself can move, how long can our familiar world maintain itself? Before the video officially starts, I need to clarify what the speed of light actually is. Many people, when they hear it, think of less than 300,000 kilometers per second, or that it's just the fastest thing. But the problem is that if you really treat it as a regular speed, you're completely wrong. Because the speed of light has never been just a quirk of photons. It is more like a measuring stick written into the background of the universe. This stick connects 1 meter with 1 second, allowing distance and time to be convertible. More importantly, it also sets the upper limit for information transmission, telling you what is cause and what is effect. In other words, without this baseline, the world would have no order. So why is it the same for everyone, no matter if you're on Earth, in a rocket, or on the other side of a galaxy? The results measured will not change. Because the speed of light is not the speed of light itself, but a property of the vacuum. The vacuum is not empty. It is more like a stage setting where electromagnetic waves vibrate, and time and space are linked. And the speed of light is the red line drawn on this setting. It is this red line that determines all actors. No matter who they are, they can only perform within the same limit. That is why the universe declares, I first set this limit and then allow you to do everything within it. Humans actually wanted to understand this a long time ago. Galileo tried. He ran to the top of a mountain with a lantern, wanting to measure the speed of light through the reaction time of turning the light on and off. But the result was, of course, a failure because light is just too fast. So scientists changed their approach. They designed a gear experiment with a flywheel, letting light pass through a rapidly rotating gear and then reflecting back from a distant mirror. If the speed of light weren't fast enough, it would be blocked by the gear. What was the result? He really calculated a value close to the actual speed. This proved that the speed of light is not infinite, but finite. But that wasn't enough. Later, Michelson and Morley wanted to prove the existence of the ether wind, because everyone believed at the time that light must need some medium to propagate, just like sound waves need air. But the more they measured, the stranger it became. No matter how the direction changed or how the Earth rotated, the speed of light remained constant. This result completely baffled people. How could there be a speed that is the same for everyone? Finally, Einstein stepped in. He didn't explain the reason. He simply took the constancy of the speed of light as an axiom. Thus, relativity was born, and space-time was tied together. Don't think that the speed of light being constant is just the result of scientific experiments. It actually plays a role in your daily life, like in navigation systems. GPS satellites orbiting the Earth depend on the time difference of light signals to determine your location. If the speed of light were not constant, even a difference of 1 second could lead to you being off by hundreds of meters. For example, in communication, whether it's making a call or going online, the essence is that electromagnetic waves are running through the air. The speed of light is their limit. If one day the speed of light changes, the information you receive will be disrupted. What you hear may no longer be the present, but a dislocated past. And in astronomy, every star we see is actually the result of light coming toward us. If the speed of light were not fixed, then the distance, age, and brightness of all stars would be calculated incorrectly, and the entire map of the universe would be thrown into chaos. In other words, as long as you can navigate with your phone, see stars, and make calls, you are constantly relying on the speed of light. But on a larger scale, the role of the speed of light is truly frightening. First, it preserves causality. What can affect what, and how the order of events is arranged is determined not by debate, but by the speed of light. As long as two events can transmit information within the limit of the speed of light, that is called causally related. Once it exceeds that line, no matter how great the force, it cannot catch up. That is absolute impossibility. The The speed of light is like a knife, splitting the universe in half. Events within the line may be related, while events outside the line are forever unrelated. Secondly, it determines the conversion between energy and mass. Why can stars burn for billions of years? It is because mass can be stably converted into energy, and this ratio is represented by the equation E equals mc squared. It's not just a pretty symbol, it's an account book of the universe. Without the speed of light, the sun wouldn't shine. Finally, it even ensures the stability of atoms. Why can electrons orbit? Why doesn't the atomic nucleus disintegrate instantly? All of this requires the speed of light to act as a constraint. Without it, chemical reactions wouldn't exist and matter couldn't form. So, at this point, the answer is already clear. The constancy of the speed of light is not a coincidence, but the fundamental framework of the universe. It unifies time and space, defines the boundaries of the universe, sets the conversion rate between energy and mass, and stabilizes atomic structure. It ignites the flames of stars. As long as this baseline exists, the world has order. But here's the question. What if one day this line actually moves? Even if it's just a little bit slower, will causality become chaotic? What if it's just a little bit faster? Will stars go out? Even a slight change? Will reality be completely rewritten? Next, we will step into this most dangerous hypothesis. If the speed of light really slows down, what will happen to the world? Many people's first reaction is that light is just moving a little slower. Stars might appear dimmer, and the cosmic night sky might seem quieter, but the truth is far more serious. Because once the speed of light slows down, it's not the brightness of starlight that wavers, but the entire order of reality. Let's start by looking at the smallest level. Why can atoms exist? It's because electrons have a stable energy state in their orbits, and this energy state calculation has the speed of light as a key parameter. If the speed of light slows down, the orbits of electrons will change, atomic radii will expand, and chemical reactions will completely lose balance. Everything around you, from air to water, from metals to blood, will lose stability. In other words, if the speed of light slows down, atoms will deform, and the world will collapse, starting from its most basic building blocks. If atoms break down, molecules will certainly not survive. The water molecules we are familiar with may not even form in today's configuration, and the spiral structure of DNA will unravel, making it impossible to preserve life's genetic information. Proteins will fail to fold, breathing and metabolism will cease. So, if the speed of light slows down just a bit, it seems to have only altered a constant, but the entire biosphere will collapse in an instant. To take a step back, even if there is some miracle that allows atoms and molecules to still exist, can stars continue to burn? The answer remains dangerous. Stars release energy by converting mass into energy, and this ratio is expressed as E equals mc squared. If the speed of light decreases, the conversion rate between mass and energy will weaken, and the efficiency of star burning will drop significantly. The sun may not ignite at all. The cosmic night sky will fall into true darkness. Without the energy of stars, planets will have no temperature, ecosystems will lack energy input, and life will have no foothold. If the speed of light slows down, the flames of stars will extinguish, and the universe will plunge into darkness. But this is just the consequence on the energy level. More seriously, it disrupts the order of the universe. The speed of light maintains the sequence of events. If the speed of light decreases, information transmission will slow down, and the connection between any 2 points in the universe will stretch longer. You might think this only means communication becomes slower, but that's not the case. Because once the signal slows down to a point where it can't keep up with the development of the event itself, the chain of causality will break. For example, when a supernova explodes, the light signal originally travels quickly to the surroundings, allowing the universe to adjust in time. But if the speed of light slows down, by the time the signal arrives, the result of the explosion has already spread, and the surroundings would not have enough time to react. The cause and effect relationship will turn from early warning to forever lost. More absurdly, the expansion of the universe will also be affected. We know that space itself is constantly expanding, with galaxies being pushed apart, getting farther apart. If the speed of light decreases, the speed of the universe's expansion may very well exceed the upper limit of the speed of light. The result is that events in some places will completely disappear from our observable universe. We might not even see most corners of the universe. The entire observable range will suddenly shrink. In other words, if the speed of light slows down, our universe will become smaller, not because space really shrinks, but because we can no longer keep up with its news. On a daily level, life will immediately lose GPS navigation, rendering it completely useless, because the signal between satellites and phones will take longer to travel, leading to positioning errors to the point of being unusable. Network communication will experience severe delays, or even complete chaos. You might make a phone call and hear a response from several minutes ago. The entire information society will turn into noise. Looking deeper, a slower speed of light will also change the meaning of time. Einstein told us that time and space are intertwined. The speed of light is the conversion rate between them. If the speed of light slows down, the spatial scale corresponding to 1 second will expand, resulting in a disconnection between the passage of time and the scale of space. We might fall into an absurd world where distances are stretched, yet time becomes fragmented. Your vaccine may not even appear as the same vaccine in someone else's eyes. All of this adds up to an extremely bizarre picture. Matter will deform, molecules will disintegrate, life will cease to function, stars will go out, the universe will fall into darkness, causality will lag, time will break, information will delay, and society will collapse. If the speed of light slows down even a little, the world will tumble like a domino effect. From the smallest atoms to the largest galaxies, all will be overturned. So we say, the speed of light is not a number that can be casually changed. It is the foundation of the entire universe. As long as it slows down, the cornerstone of the world will become unstable. Then the question arises, what if the speed of light doesn't slow down, but becomes faster? What will happen? Will it collapse in the same way? Even more dangerously than slowing down? Next, we will continue to extrapolate another extreme. What would a universe with an accelerated speed of light look like? Many people's first reaction is, isn't that better? Light travels faster, information travels faster, and the universe becomes more efficient. But the truth is far from that. Once the speed of light accelerates, the consequences can be even more absurd than slowing down. Because it doesn't change efficiency, it changes the baseline of reality. Let's start with the chain of causality. The speed of light is important because it delineates the boundary of causality, telling you which events can influence each other and which are destined to be unrelated. If the speed of light suddenly increases, the chain of causality will be reshuffled. The influence that used to take years to transmit might now be completed in an instant, resulting in a disorder of the order of events, and the boundary between the future and the past will become blurred. In other words, an increase in the speed of light doesn't make the world clearer, it makes the flow of time more chaotic. Next, let's look at the atomic level. The stability of atomic structure relies on the speed at which electrons move in their orbits, and the balance with the speed of light. If the speed of light increases, the upper limit of electron speed will also rise, and the orbit will change. Atoms may become overly compact and even collapse directly. The way molecules bond will be rewritten, and chemical reactions will no longer follow the familiar rules. In other words, the very fundamentals of matter will be forcibly rewritten. The world may no longer be composed of the elements we know. Now, looking at stars, if the speed of light speeds up, the conversion rate between mass and energy will also be magnified. In the equation E equals mc squared, as c becomes larger, c squared represents astronomical expansion. The result is that the same amount of mass can release energy far beyond what it can today. The burning of stars will become extremely violent. The frequency of supernova explosions will increase significantly, and galaxies will explode in chaos. The universe will no longer be a gentle sea of stars, but rather a hell filled with violent explosions. So what about the information society? On the surface, it seems that with the speed of light increasing, signal transmission becomes more efficient, as if humanity is entering an era of zero latency. But the problem is that all communication protocols, all navigation systems, and all physical measurements are built upon the premise of the constancy of the speed of light. Once the speed of light increases, clocks will go awry, satellite positioning will become chaotic, and data transmission in computer chips will also get disrupted. The result won't be higher efficiency, but rather the entire information society will fail instantly. More seriously, if the speed of light accelerates, it will directly disrupt the energy balance of the universe. Stars will release stronger energy, and the background radiation of the universe will soar, leading to an increase in temperature. The structures between galaxies may be blown apart. You can imagine the entire universe as a pot of water suddenly heated, bubbles constantly emerging, and the originally stable structure being shattered. What about time? We know that the speed of light is the conversion rate between time and space. If the speed of light increases, the ratio between time and space will be rewritten, resulting in time appearing shorter and shorter, while space appears longer and longer. 1 second of ours may become meaningless on the scale of the universe. The boundaries between past and future will be distorted, and you may encounter an absurd situation where something that just happened feels like it happened a long time ago, while the future has yet to arrive but has been overdrawn in advance. In more extreme cases, if the speed of light accelerates infinitely, causality will completely collapse because there will no longer be transmission time between events. Everything can connect in an instant. The result is that the concepts of cause and effect will lose their meaning, and the world will become a chaos where the distinction between before and after is impossible. This scenario is scarier than the speed of light slowing down. At least slowing down can retain part of the causality chain. It is merely delayed, but speeding up would completely tear apart the causality chain, causing the entire reality to lose its order. Matter will collapse, stars will explode, galaxies will disintegrate, and time will distort. Causality will vanish. Once the speed of light accelerates, the universe will no longer be the universe, but will become a chaos that cannot be controlled. So at this point, we reach a conclusion. Whether the speed of light slows down or speeds up, the consequences are disastrous. The constancy of the speed of light is not just a random choice of the universe, but the only way to maintain order. The question is, how strong is this constancy? How is it related to other natural constants? If the speed of light is not just a single chain, but an entire web, are we touching the most dangerous secret of the universe? Next, we will look at this web of constants and see the role the speed of light plays in it. By now, we have seen that if the speed of light slows down, principles will collapse. Stars will thin out. If the speed of light speeds up, causality will become chaotic, and the universe will explode. Then the question becomes sharper. Why must the speed of light be fixed at this value? The answer lies in the fact that it does not exist in isolation. It is tied to a larger web. In other words, the speed of light is like a gear, and once this gear moves, the entire machine will collapse. Let's first see what this web contains. One of the most famous constants is the fine structure constant, which determines the strength of interactions between electrons and photons. The speed of light plays a key role in this ratio. If the speed of light changes, the fine structure constant will also change. What are the consequences? The energy states of atoms will become completely unbalanced, spectral lines will misalign, and chemical reactions will no longer hold. In other words, even if the speed of light changes by just 1%, the entire chemical world will be overturned. For example, consider the gravitational constant. Why is gravity so weak, while electromagnetic force is so strong? The proportions between them cannot do without the speed of light, because the ratio of mass to energy is written in E=mc². Mass is closely linked to gravity. If the speed of light changes, the relationship between mass and energy will also change, and the strength of gravity will be affected as well. The result is that galaxy structures will collapse, planetary orbits will disband, and whether the solar system can exist completely depends on whether the speed of light is stable. There's also Planck's constant, which determines the scale of the quantum world. All calculations in quantum mechanics are tied to the speed of light. Planck length, Planck time, Planck energy all are defined by the speed of light. If the speed of light changes, these scales will also jump. The laws of the microscopic world will all change. The macroscopic world will also lose support. It's like thinking you only replaced one screw, but the whole building is shaking. This is the terrifying aspect of natural constants. They are not just a bunch of lonely numbers, but an entire network of interlocking gears with the speed of light right in the center, linking both the quantum world and the macroscopic universe. As long as it moves even a little, the other constants must change in unison. The question is whether they can change simultaneously. If they can't, the result will be that the entire machine freezes up and reality will crash. Scientists have long been aware of this issue. This is what is called fine-tuning. What does it mean? It means that these constants in the universe seem to be perfectly set. If the speed of light were even a little larger, stars would burn too quickly for life to emerge. If it were a little smaller, stars might not ignite at all, and the universe would fall into silence. To what extent is it fine-tuned? Even a change of 1/100,000 could prevent life from existing. The fact that we can sit here and think today relies on that delicate balance between the speed of light and other constants. So some have suggested that the fact of human existence itself is evidence that the speed of light is fixed, because if it could change randomly, we wouldn't have the opportunity to ask this question. This is the so-called anthropic principle. It sounds a bit philosophical, but it actually reminds us that the constancy of the speed of light is not accidental. It is a result of the universe's self-regulation. But the question arises, if the speed of light is tied to the entire web of constants, how strong is that web? Is it a rule set by the universe from the very beginning, or is it a habit that has evolved over time? In other words, is the constancy of the speed of light an innate truth, or is it a product of evolution? If it is predetermined, it means that from the first moment of the universe's birth, it was locked into this set of parameters, and we are merely living in a forcibly fixed version of reality. But if it evolved, then the question becomes even stranger. Who is adjusting this parameter? Who is selecting this value for the speed of light? Why is it suspended in a Grayston range that allows for the existence of life? Does this imply that the universe has a self-regulating capability? Once you think this way, the speed of light is no longer just a fixed number, but more like an instinct of the universe. It is not a solitary rule, but a contract of mutual interdependence. All constants interlock, and none can be missing. The speed of light is merely the most prominent thread, while the entire web is the true secret. This pushes the question to a philosophical level. If natural constants form a web, does it resemble a language of the universe? Each constant is a letter, and the speed of light is the grammar. It is precisely because these letters are combined perfectly that we can read a comprehensible reality. If these letters can be altered at will, the entire language will fail, and the universe will turn into a jumble of nonsense. Therefore, the speed of light must not change because it does not exist in isolation. It is the point of intersection for all rules. Moving it is akin to tearing apart the entire web. Then the question arises, who created this web? Why does it allow us to understand? Is it an innate truth or a habit acquired over time? So we must continue to question what is hidden behind the constancy of the speed of light. Is it a necessity of nature or a choice of the universe? Why is the speed of light constant? Earlier, we saw that it intertwines with natural constants, moving in unison with the whole. That is why it seems unmovable. But the deeper question is, what kind of property does this constancy belong to? Is it a truth, a rule written into the universe from the start, or a habit, a choice that gradually solidified over the course of cosmic evolution? This is not a trivial question, because different answers completely change the meaning of the entire universe. If the constancy of the speed of light is an innate truth, it implies that the universe began with a complete script, like a movie that decided its final scene from the very first second. The speed of light, as a key line in the script, leaves no room for modification. Even if you try to shake it, all you get is futility. The advantage of this understanding is that it is logically coherent because everything strictly follows the rules. But the cost is heavy. The universe has no freedom at all. Life is merely a passive product. Our existence is not a miracle, but a necessity. All your and my choices are essentially illusions. But what if the constancy of the speed of light is not an innate fact, but a product of evolution? Then the picture changes completely. You can imagine the universe at the start as a chaotic draft, various constants bouncing around, shaking like a head. The speed of light may have once been faster or slower, but through countless collisions and trial and error, the universe gradually settled on this set of parameters today. In other words, the universe seems to be self-regulating, ultimately selecting a version that can maintain stability and foster life. This way, our existence is the outcome of selection rather than an inevitable fate. It sounds quite esoteric, but within the scientific community, there are indeed people who have proposed similar ideas. Some physicists suggest that the so-called laws of nature may not be innate, but rather habits formed through the long evolution of the universe. Just like rivers, which form fixed channels through long-term erosion, the evolution of the universe may solidify certain rules over time. The constancy of the speed of light could be the channel formed by the universe's evolution. It wasn't there from the start. Time shaped it into what it is today. This idea has a shocking consequence. The rules may not be absolute. If they can form, they can change. It's just that within our observable timescale, they appear eternal. But what about on a larger scale? Hundreds of billions of years, thousands of billions of years later, will the speed of light subtly change? Will the universe enter a new phase? If that is the case, then what we call physical truths are merely temporary habits. The question is, if the constancy of the speed of light is just a habit, who is maintaining it? Is it the universe itself? Or is there a deeper law behind it, guiding the constants towards stability? It's like a paradox. If all rules are habits, then where do the rules of habits come from? From a philosophical standpoint, there are two paths. The first path is determinism. The speed of light has never changed and cannot change. The universe is a tightly knit theater. The second path is evolutionism. The constancy of the speed of light is simply the optimal solution. The universe chose parameters that can maintain stability. These two paths concern not only physics, but also how we understand ourselves. If it is the former, we live in inevitability. Everything is written into the code. If it is the latter, we live in choice. The universe is like a branch, and we are the lucky ones who landed at this point. As a result, can you feel the difference? In the first universe, we are passive roles. In the second universe, we are fortunate winners. So which one is true? Science has not yet provided an answer. What we can observe is that the speed of light remains constant in almost all cases, showing no signs of fluctuation. But we cannot prove that it is absolutely invariant on a larger scale. It's like standing by the river for 100 years, seeing no changes in the riverbed, and believing it will always be so. But who dares to guarantee that it won't change course after millions of years of erosion? So, is the constancy of the speed of light a truth or a habit? This is the deepest question we can reach. If it is a truth, then the universe is a perfect archive, cold and inevitable. If it is a habit, then the universe is a process of evolution, open and uncertain. Regardless of which explanation, both lead us to a new ultimate question. If rules can change, can we perceive that change? If one day the speed of light truly shifts, will the universe leave us visible traces? Let's first look at the most intuitive evidence. The farthest light we can see today is the starlight from over 10 billion years ago. In other words, those photons set out from the universe's infancy and ran all the way to today before reaching our eyes. They are natural historical witnesses. Scientists have conducted countless spectral observations, comparing the light emitted by distant galaxies with the light in today's laboratory, and found almost no difference. This means that, over billions of years, the speed of light has not shown any visible changes. However, scientists are not satisfied with almost no change, because even a deviation of 1/100,000 is enough to shake the entire physical system. So they sought more methods, such as utilizing quasars as spectra. Quasars are among the brightest celestial bodies in the universe. Their light passes through the gas in the universe, and certain absorption lines will be left by meteors. If the speed of light had changed, these absorption lines would be misaligned. After decades of observations, most results still support the constancy of the speed of light. However, some studies claim that there may be extremely tiny deviations. These results have not been widely accepted, but are enough to send chills down one's spine. Next, let's look at evidence from laboratories. Scientists use atomic clocks to detect the stability of constants because the vibration frequency of atomic clocks is directly related to the speed of light. If the speed of light were changing, atomic clocks would slowly drift. For decades, humanity has created increasingly precise atomic clocks, accurate enough to measure 1/11 of a second. The result? Within our observable time frame, the speed of light remains stable, with no signs of drifting. But does this mean that the speed of light will never change? Not necessarily. The time we can measure is just a moment in the universe's history. You can imagine it as standing by the river for a few minutes and thinking the flow is steady. But if we expand it to thousands of years, the river could have changed long ago. So, some theories suggest that the speed of light might gradually adjust with the expansion of the universe. It's just that this change is too small and too slow for us to capture it. There are even more extreme views. Some physicists speculate that during the universe's inflationary period, the speed of light might have been much greater than it is today because, at that time, the rate of space expansion far exceeded what it is now. If the speed of light were the same then as it is now, the universe's uniformity would be impossible to explain. In other words, the speed of light may have been a variable parameter in the beginning, gradually stabilizing over time. Although this idea lacks direct evidence, it can explain some problems that the standard model cannot. If these speculations are true, it means that the constancy of the speed of light is merely a local phenomenon. In this segment of observable universe history, it appears to be ironclad, but in earlier or farther regions, it may not be fixed. Just like we see a straight road, but further down, it may have long since turned. The question is, if the speed of light truly changed at certain scales, what traces would it leave behind? The answer may be hidden in the cosmic microwave background radiation, which is the earliest light of the universe, born 13.8 billion years ago, still echoing in the sky today. If the speed of light was different then than it is now, the temperature distribution of the microwave background would also differ. Scientists have indeed discovered some strange asymmetries and cold spots in the microwave background. Although mainstream explanations haven't pointed to the speed of light, this possibility has never been completely ruled out. So now, we face a situation where, within measurable limits, the speed of light appears constant, but on distant scales, it may have changed. Yet we have no conclusive evidence. Just like a closed door, scientists press their ears against the door, mostly hearing silence, but occasionally picking up vague sounds. Are those just illusions, or is there really something moving behind the door? No one can provide a definitive answer. This leads us to a new philosophical dilemma. Is the constancy of the speed of light a local truth? Is it unshakable in this small segment of cosmic history, but possibly just a temporary compromise on a larger scale? If that is the case, then what we call scientific eternal laws are actually just long-standing habits. Once those habits change, the reality we rely on will also be completely rewritten. So the question ultimately comes down to this: is the speed of light an unchanging truth or an illusion with tiny cracks? Can we find conclusive evidence? Has the universe already quietly left fingerprints of the speed of light drift in some place? Next, we will inquire into another larger question. If the speed of light can really change, who is controlling this script of rules? Is it nature itself adjusting, or is there a deeper mechanism operating in the shadows? Once this question is raised, it confronts us with the universe's most sensitive mystery. Does the rule itself also require a creator? First, let's consider the first possibility. The change in the speed of light might be a natural result of the universe's evolution. Just as rivers wash out valleys and slowly change course, the parameters of the universe may also fine-tune over time. If that's the case, it means the speed of light isn't being rewritten by someone, but rather that the universe itself is breathing, going through a long metabolic process. The speed of light during the inflationary period may have been much faster than it is today, and after 10,000 years of evolution, it gradually stabilizes at today's value. This picture tells us that the universe does not have a fixed script. It resembles a self-learning machine, finding balance through repeated attempts. But the other possibility is even more unsettling. The constancy of the speed of light is too finely tuned, as if someone has precisely adjusted it to a range that can just support life. The fine-tuning problem has long troubled the scientific community. Why are these constants precisely these numbers? Why is the speed of light neither larger nor smaller, but exactly within the range that allows stars to ignite and principles that stabilize the existence of life? Is this merely a random coincidence? Some may say that this is the anthropic principle. Why are these numbers the exact constants? Why is the speed of light not greater or lesser, but precisely within the range that allows stars to ignite? Is this just a random coincidence that defines the stable range for life? Some might say this is the anthropic principle. The very fact that we can pose this question is due to the speed of light falling within this interval. But this explanation sounds more like an excuse rather than an answer, leading to another hypothesis being proposed. Is there really some kind of underlying rule helping the universe select parameters? If such a rule exists, what could it be? One guess is the multiverse theory. What if our universe is not unique, but has countless versions, each with different constants? Then the value of the speed of light would be like the result of an investment. Most universes probably don't have stable matter or have collapsed shortly after their birth. Only a very few universes have parameters that are just right to ignite stars and foster life. And we just happen to live in one of those lucky universes. This explanation sounds spectacular, but the problem is that it will always be hard to verify. We can't run off to another universe to measure it, nor can we know what the speed of light is there. It feels more like a logical refuge that allows us to temporarily avoid answering the difficult question of who is tuning the parameters. There's also a more radical viewpoint, which is the simulation theory. Some believe that our universe might essentially be a program, and the speed of light is a fundamental running constraint written into that program. Just like the maximum speed in a game isn't decided by the character, but hard-coded by the system. If the speed of light can really change, it might mean the programmer is updating the patch, adjusting the operating parameters. This idea sounds like science fiction, but it explains one issue: why the rules are so rigid yet so precise. Because they were designed that way. The problem is, if there really are programmers, who are they? On what level do they exist, and why did they set this particular number? This question currently has no answer, but it makes one shudder. Of course, there's a third possibility. The reason the speed of light is constant is that our way of understanding the world can only see this facade. In other words, the speed of light might not be the ultimate rule of the universe, but just a constraint within our cognitive framework. Just as 2D beings cannot imagine 3D space, we might also be unable to see the higher dimensions behind the rules. If the speed of light really can change, it's not the universe moving, but our method of measurement that is changing. It's our understanding's coordinate system that is shifting. This explanation pushes the question back to consciousness and cognition itself, reminding us that what we call constant might be an illusion of our minds. Regardless of which explanation we consider, the notion that the speed of light can change forces us to confront the same intermediate question. If the rules are not absolute, what is it that sustains the reality we depend on? Is it the evolution of the universe itself, the selection of multiple universes, some kind of simulation setting, or the limitations of our cognition? Any of these possibilities could completely overturn our understanding of the world. So when we ask who is rewriting the script, the real question is whether the universe has a script at all. If it does have a script, then who is the writer? If it doesn't have a script, then is the constant speed of light just a habit? Can what we call truth still be considered truth? Next, we need to delve further into this dilemma. We should ask whether the constant speed of light is merely a temporary facade. Is it possible that the universe could completely modify this rule one day in the future? And when that moment truly arrives, will we be the first to notice as witnesses, or the last to be erased as bystanders? This isn't a hypothetical game, but an ultimate test of survival. Because if the speed of light is rewritten, what is shaken is not just a value from an experiment, but the very foundations of civilization. First, science would become instantly invalid. All of our equations today are predicated on the constancy of the speed of light. If that's rewritten, Einstein's theory of relativity would collapse. Quantum mechanics would become inaccurate, and the standard model of cosmology would disintegrate. At that moment, all the knowledge written in textbooks would turn from truth into waste paper. Humanity's accumulation over centuries would vanish in an instant. You can imagine scientists staring at the values on their instruments and every formula reporting errors. That kind of shock would send the entire world into a panic. Then technology would fail comprehensively. GPS navigation would lose its coordinates. Communication networks would become chaotic. Satellites would fail, and the synchronization mechanisms of computers would be completely disrupted. A message you send could be delayed by seconds or even decades before it arrives. Aerospace, energy, and healthcare would all come to a standstill because their operational logic is all based on the assumption that the speed of light does not change. Once this premise collapses, human civilization would be like a skyscraper that has lost its foundation, ready to topple at any moment. Worse still, causality would be shaken. The speed of light is the referee of the causal chain. It dictates what can affect what and what can never be connected. If the speed of light is rewritten, the causal chain would loosen, and the boundaries between the future and the past would become blurred. What would be the result? Our logic would be torn apart. You might do something that has already spread before it even happens. If you try to prevent a disaster, you could forever fail to catch up with its signals. This kind of causal order not only indicates the collapse of science, but also the collapse of cognition. At that moment, we might no longer be able to distinguish what is before and what is after, what is the cause and what is the effect. How would humanity respond? The first reaction would definitely be panic. Financial markets would crash, social order would destabilize, and rumors would run rampant, because once the foundational rules loosen, everyone would feel the world is no longer reliable. But after the panic, humanity would enter a second phase of frantic reconstruction. Scientists would desperately seek new rules, trying to write new equations to explain reality. Perhaps we would discover that the speed of light is not the only limit, but a projection of some deeper laws. Maybe we would be forced to topple the entire physical system and build a new science on the ruins. But the question is, does humanity have enough time to rebuild? If the change in the speed of light is drastic, then before we find new rules, the universe may no longer allow us to exist. Atoms would disintegrate, stars would extinguish, energy would become unbalanced, and the entire environment would no longer be friendly to life. We might even be erased before we understand what has happened. In other words, a rewriting of the speed of light could very well be an end for humanity, not a challenge. Of course, there's another possibility. If the change in the speed of light is gradual, happening over a scale of 10,000 years, then humanity would have the chance to adapt. Perhaps we could catch signs of it in advance, adjust technology, update theories, and even push civilization to a whole new level. We might discover new communication methods, new energy sources, and new maps of the universe. In that case, the change in the speed of light would not mean destruction, but rather a cosmic upgrade. However, this would require humanity to possess wisdom and resilience far beyond what we have today. But regardless of which outcome it is, the moment the speed of light is rewritten will become the ultimate test of human civilization. It will test our obsession with truth and our courage in the face of the unknown. If we can find new rules, we can rebuild civilization on the ruins. If we cannot, then we might become a fleeting footnote in the annals of the universe. So this question ultimately leads us to philosophy. If the speed of light can really be rewritten, can we accept that truth is not an eternal fact? Can we still believe in so-called laws, or should we acknowledge that the universe has never guaranteed us anything? It can change its rules at any time, and we are merely temporary bystanders. Having reached this point, we know that the speed of light seems to be just a speed, but in reality, it is the foundation of the universe. It stabilizes time, stabilizes causality, and also stabilizes the order of matter and energy. We have deduced that if it slows down, atoms would scatter, stars would thin, and causality would lag behind. The universe would plunge into a dead end. If it speeds up, matter would collapse, stars would explode, causality would become chaotic, and the world would be lost. It entangles itself with other constants, forming a web. Any minor change could cause the entire machine to jam. The question is this constancy a truth or a habit? In the space-time we can observe, it is as solid as iron law, but at much more distant scales, it might quietly loosen. If one day the speed of light is rewritten, humanity will have to either rebuild the rules or disappear in an instant. So the constancy of the speed of light is not a gift from the universe, but rather its only allowance for our existence. In other words, as long as the speed of light remains, but rather it is the only allowed existence for us. In other words, as long as the speed of light remains, the universe exists. However, if it were to change, would the world beneath our feet still be called a world? This is the ultimate question we leave for everyone today.